Hi, I want to show you a cool thing I built called the Calculus Machine, and it's hopefully going to help you learn a little about calculus. Click the link below to go to a live version of this graph that you can play with yourself. The Calculus Machine was built in Desmos, which is an incredibly powerful online graphing calculator. Let me show you how this works. As you may already know, calculus is a set of tools for exploring how functions change. This red shape here is a function, and we're going to create the graph of its derivative. The derivative is one of the most important concepts in calculus. In simple terms, the derivative of a function describes how that function is changing. The tool I want to show you, the Calculus Machine, measures how much a function is changing at each point, and then uses that information to draw a new graph. This new graph we create is the derivative of the first function. Let me show you how we do this. We start by drawing a tangent line. Now, the tangent line is a line that touches the graph in just one place. If you were to zoom in very, very close, you would see that the line doesn't cross, but just barely touches in one place the graph of this function. You would also notice that as we get close, the slope of this blue line is the same as the slope of this red function. In other words, the tangent line is changing at the same rate as the function. So we can use the tangent line to help us measure precisely how our function is changing at each point. We do this using slope. Slope is the change in y divided by the change in x. You might have heard it described as rise over run, or delta y over delta x. The key thing here is that slope is a way of measuring how steeply a line is increasing or decreasing. A very large positive slope means rapid increase. You can see that here. A very large negative slope means rapid decrease. The closer that the slope is to 0, like it is there, the closer the function is to neither increasing or decreasing at all. We measure slope in terms of how much the y value changes every time the x value changes by 1. So in this case, I'll draw a little horizontal purple line that's exactly 1 unit long. So now you can see that the amount that we go up to get to the blue line here is the slope of the tangent line at this point. It's also a way of representing how much the function is changing at that point. So when the tangent line is very steep, then this red line is going to be very long. And then as the tangent line gets flatter and flatter, the red line gets shorter and shorter. And then as the tangent line gets more and more of a negative slope, the red line gets longer and longer in the negative direction. You can see there the red line is pointing down. There the red line is pointing up. A key thing to note here is that the red line is corresponding to this point here. This change here is telling me how the function is changing at this point. So what I want to do is keep track of that. Let's see. There we go. And now I can use this information to actually draw the graph of a new function. So let me put another axis down here. And let me just drop down a green line so that I know that I'm taking the information that goes with this point and matching it here on the graph. And remember, the derivative tells me how the function is changing at that point. And this red line is telling me how the function is changing at this point. So what I'll do is I'll just take this same red line here and recreate it down here. So now as I move along the original function, I can see this same red line copied down here. And what that's showing me is how this function is changing at each of the points along the function. And you notice here, where the function is neither increasing nor decreasing, the red line has gone down to 0, and right here the red line's gone down to 0. And then as I continue to move forward, and the function actually starts to decrease, you can see that red line moving down beneath the axis. So the next step is just to actually go ahead and mark those points. So now as I move my point along the graph of f, I'm making little dots that are keeping track of how f was changing at each of these points. And remember again, right here is the point where f was neither increasing nor decreasing, and that matches the place where this derivative function has a value of 0. If you like, you can put a line through it. And that is a demonstration of why this function, this line here, is actually the graph of the derivative of this function here. Okay, play with it. Let me know what you find out.